the last case here. To form the equation is the most important part, but when you solve, I'm sure you guys are okay with that. So this case gonna be with driven motion. So that means there is the external force involving kind of the full version. The full form, the m times second derivative beta times the first derivative. That's from the damping constant, damping force, and then kx is this is from the spring. And f at t is not zero for this case, or you are working on the non-homogeneous equation. F at t is the external force. You can rearrange the term, making it as the leading coefficient, or the coefficient of the leading order to be 1, so make it cleaner. So this case, it kind of help you see the relationship of each parameter. Like if you divide all by m, so the 2 lambda is the beta over m. That is a damping force per the mass, and the k over m, that's the omega. Okay, so that is the k over m, or the omega, which is the angular velocity. If you recall, we went over at the very first case. So this case, again, the solution, you're gonna have to find the complementary solution and the what do you call, the particular solution as you solve the non-homogeneous equation. Okay, and the force here usually in the oscillation force, kind of for the typical case, it's going to be the force. For example, the spring. Let me draw it. The case that you have the spring and you have the mass here, and then it's attached to some force that tied to the fixed wall. And when you force it, it go back and forth, back and forth, back and forth, bounce back and forth in the oscillation motion. So most of the time, it has the trick term involving into the external force. Okay, so for the first one here, just to analyze or explain what's going on into the equation, it didn't. Well, I did the whole thing for you, so I will walk you through real quick. Okay, as you see this as 1 over 5 times the acceleration, and 1.2 times the velocity, and 2 times the x, and the 5 cosine 4t with the initial condition, initial position, initial velocity. So for each one of them, as we analyze real quick, the 1 over 5, that's the m. So that is the m as a mass, which is 1 over 5. If this is unit in the English system, it's going to be 1 over 5 slug. Okay, metric system going to be kilogram. 1.2, that's a damping constant, or the beta. So this one is the beta. Okay, and the 2 is the spring constant. So this is the K. Okay. Okay. The 5 cosine 4t, that's the external force. The x at 0 equals 1/2. This is a plus sign. Plus sign means below the equilibrium position. X prime 0 equals 0. That means at the rest, from the rest. Okay. And to solve, just follow the process in chapter 4. And as you see, the oscillation of the solution, well, it's going to take about like 2 pages to get to this solution. So for the graph to explain the behavior, um, the blue curve here, let me expand it a little bit. The blue curve is behind the yellow curve. The blue curve is the graph to represent the motion or the position of the object or the mass at the time t. So you see this at rest. So that means the slope at the first position is 0, and positive, that means it's below the equilibrium position, and starting with going up and then bounce back and forth because of the external force in the cosine form. So it's gonna cause it as an oscillation. And then when you look at the transient or the steady state, you take the limit of the solution. The transient term, the term that goes away eventually, so that involving the exponential. So this term goes away. So eventually the behavior of the graph gonna go with the sine cosine pattern or the oscillation pattern. So that means steady state. So eventually it's just go with the periodic form of the pattern. Okay. So let's form this equation real quick, and then I can describe more with the graph of the solution. This one, let's put the key term again. This time slug already give you a mass of one slug attached to springs, stretched 2 feet and then comes to the rest in the equilibrium position. Starting at T0, external force F at T is e to the negative T times sine 4T. Find the equation of motion if the surrounding medium is offered a damping force numerically equal to 8 times the instantaneous velocity, and then analyze the displacement for t approaches infinity. All right. So what we have, the m equals 1. Yep. And then stretch 2 feet. Stretching 2 feet. So that means, so this part, if we use f equals k, oops, sorry, k times x, so the force here gonna be 1 times 32. So this, the weight is 1 times 32. Okay. So gonna be 32 equals k times 2. That means we get k equals 32 over 2, which is 16. Okay, 32 divided by 2, or 16. Cut unit is here and there, so you have to think about the appropriate unit for the appropriate quantity for the certain quantity. So we have m equals 1, k is 16, and then at t equals 0, the external force, the ft, is e to the negative t sine 4t, and the damping force 8 times the velocity, so the b equals 8 as the damping constant. What else did we have here? Starting T0, motion, the surrounding, stress these, then come to the rest in equilibrium position. Rest equilibrium position. So from those two pieces, the x at 0 is 0. The x prime at 0 equals 0. The rest here, x prime equals 0. Equilibrium position, x at 0 equals 0. Okay. Then the equation of the motion, or the differential equation, which is from the m x double prime plus beta x prime plus k times x equals the f of t, or the full version. So m is 1 times x double prime plus 8 times x prime plus 16 times x equals e to the negative t times sine of 4t. Okay. And for the complementary part, which is from the homogeneous of x double prime plus 8x prime plus 16x, we use the same information as one of the examples earlier, as m equals negative 4 and negative 4, right? So the xc equals c1 e to the negative 4t plus c2 t times e to the negative 4t. And then to find the xp, since this is not the same pattern as the two exponential term as part of the complementary solution. So the xp form gonna be in the form of e to the negative t times a, remember, cosine 4t plus b times sine of 4t. They come as a package, sine cosine. It's more work to do for the complementary solution, because you have both exponential and the and the sine cosine form. So I'm gonna give me a couple minutes and I'll wrap this up. Sorry about that. So to find the xp, as what you did before, you find xp prime, you find xp double prime, and satisfy this equation, right? Cheat sheet, okay. Dot, 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 the process, you can follow up with my notes later. So the xp is in the form of negative 1 over 4 times cosine of 4t. Nice, huh? Now put them together. The solution, the x at t equals c1 e to the negative 4t plus c2 t e to the negative 4t, and then minus 1 over 4 cosine 4t. This is the longest process for the damn external force motion or different motion. So with the whole thing here, find C1 and C2. C1 equals, cheat sheet again, C1 is 1 over 4 and C2 is 1. From using x at 0 equals 0, x prime at 0 equals 0. Give you these two numbers. I I feel like it's tedious if I show you again how to work on it. Just give you the overview. Therefore, the pattern of the solution is C1 equals 1 over 4 e to the negative 4t plus 1 times t times e to the negative 4t minus 1 over 4 cosine 4t. Recall, you cannot use the initial condition until you get the xp as part of the solution. Okay, so from this solution form, you can see the graph. The graph will be as the blue one. The blue one is the graph of the solution as 1 over 4. Since you see at rest, so that means the slope at the first position is 0, the position at the beginning as 0. And then it goes up and down, and eventually it's going to go with the cosine graph, because when you take the limit as t approaches infinity of the xt, this term go away, this term go away, and then the limit will be negative 1 over 4 cosine of 4t. So it will go with the graph of the yellow curve here eventually. So in the long term, it will oscillate like the cosine graph. All right, so that's a wrap up for the external force involving into the system. So the first part is the most important one. Have make sure that you get the right M. If K is provided, that's great. If not, you have to put together using the Hooke's law. If the beta is provided, you can see the key term as a damping force as how many times or the factor of the instantaneous velocity.